Previous year JEE question, a charged particle moves through a magnetic field perpendicular to its direction. Then, path of particle will be, is it A, spiral, B, ellipse, C, circular, or D, none of the above? You've probably heard this fact. A charged particle moves in a circular motion when a magnetic field is perpendicular to its direction. But why it create a perfect circle? Why not just a slight bend or a spiral? Today, we're not just memorizing the rule. We're visualizing the invisible forces at play. Let's break it down step by step. Imagine a charged particle like an electron or a proton moving with velocity v. Now, it enters into a magnetic field, B, and this magnetic field is perpendicular to the particle's direction of motion. Effect of magnetic field can be explained with Lorentz law. The force F on the particle equals to its charge Q times the cross product of its velocity v and the magnetic field B. Forget the math. The crucial point here is that the force is always perpendicular to both the direction of motion and the field. Now here's the key idea. Since the force is perpendicular to the velocity, it cannot change the speed of the particle. It only changes the direction of motion. A force that constantly changes direction but not speed causes circular motion. So the magnetic force acts like a centripetal force, keeping the particle moving in a circle. You might be surprised that this isn't just textbook stuff. This is how cyclotrons and mass spectrometers work. They use this circular motion to accelerate particles or sort them by mass. The radius of the circle tells scientists about the particle's mass and energy. If this explanation helped you, hit the like button, subscribe for more physics made easy, and drop your questions in the comments.